I'll show you that when we get there, okay? All right, so let's go through each one of these. These are the different types that are on the assignment today, okay? And then we'll do one more. We'll do number 17 also off the assignment before you get started. Okay, so let's begin. So the key thing is, again, pedal backwards. Get rid of addition and subtraction before you get rid of multiplication and division. That's where most kids mess up. So what is happening to this x? What is on the same side? Because remember, what is your overall goal? Get the x by itself on one side of the equation. So what is on the same side of the equation as the x, Griffin? What's on the same side of this equation as the x? What else is on that side? The -4 and the 3. That's what I'm going to have to get rid of. But I have to order of operations backwards to get rid of it. Okay, so Logan, what should I get rid of first? How do I get rid of a -4? And again, you're pedaling backwards, so think opposite. Think backwards. If it's -4, what should I do, Logan? Add a 4, right? That's the opposite. See, I'm going to add a 4. If I add it to the left, I got to do what? Add it to the right. I see a lot of kids add this 4 and then they forget to put it on the other side. What's his name? Camden? Dang it, I get it wrong every
Looking
time.
at you,
Seth.
Oh.
Seth does this all the time. He'll put a +4, he'll cross it out, he says, boom, I'm good, and then he forgets to put it over here. Don't do that. You gotta put 4 on both sides of the equation.
Make your
So
Scales
make sure
equal.
you keep it even, right? That's what the whole point of an equation is. You're trying to keep it equal. Whatever you do to the left, you gotta do the right. 2 girlfriends, right?
Yeah.
You can't be treating one girlfriend different than the other one.
Okay.
If you add 4 to one, you gotta add 4 to the other. It's like kids also, by the way, when you get to be parents. They're always saying, that's not fair, that isn't what you did with your sister, or your brother, or whatever. And I'm like, well, they're different people. But never mind, we'll treat you all the same. We're gonna add the same thing to both sides. Okay, so that's what we're doing. So now we have 3x over here on the left equals 17 plus 4. What is 17 plus 4? What's your name? Rayleigh, what's 17 plus 4?
We got
21. Okay. Gannon, what should I do next?
You, I don't know.
Well, here's the equation. What do I need to get rid of?
Divide 3 by 21.
I gotta divide. How come I'm dividing? How come I'm dividing? This means 3 what x? Times x, so I do the opposite, just like we were talking about. Always pedal backwards, always do the opposite. So we're dividing by 3, x is what? 7. Is that right?
Yes,
How do you know?
because I did the math.
Okay. What'd you get then? Danny?
Huh?
What'd you get
7.
when you did the math? No, 7 isn't right. What'd you get when you did the math? You said you did the math.
Yeah.
So what'd you get?
7.
No. If you did
That's
the math,
not
you wouldn't have
math.
got 7, you would have got 17. If you did the math.
Why would I get 17?
Ah, exactly. That's what we're going to check. So 7 times 3 is what?
21.
21 minus 4 is?
17.
Did you do the math?
Yeah.
Now you did the math. So this isn't doing the math. This is getting the answer, right? But to check your answer, to see if it's right, just plug it in. It takes 2 seconds and just do it in your head. 3 times, just like we just did. 3 times 7 is what?
21.
21 minus 4 is?
17.
If it's equal, obviously you did it right? That's the whole point of an equation.
and
To
you
make
could
sure
use
that-
your calculator to check it.
Okay. But you don't have to check it, but it's just a smart thing to do to make sure you got it right. Okay, Brian, this one's a little bit harder because how many things are with the x? How many things are doing stuff to the x?
-7 and 2.
I have a -7, I have a 2, and I have a lot of stuff over there, right? So I got to get rid of the 3, the -7, and the 2, but I still have a pattern that I've already established, which is pedal what?
Backwards.
Backwards. Can I get rid of the 2? Why would I get rid of the 2 first? It gets rid of the division what? Line. I want to get rid of the division line first. Right? I want to get rid of that. So what is the 2 doing to all that stuff on the top?
Dividing.
Dividing. Very good. So what's the opposite? Again, when you're pedaling backwards, you got to think opposite. What's the opposite of dividing? So I should times both sides, this equation and this side by what?
2.
By 2, right? What's your name?
Mine?
Yeah,
Addie? Oh, wait, what?
not Addie, you.
Gianna.
Gianna. So Gianna, when I times this side by 2, what happens with this 2 and this 2?
They cancel out.
They divide, I don't like the word cancel, they divide to 1. 2 goes into 2 how many times?
Once.
1. What's 1 times all that? All that, right? So I'm just gonna write 3x minus 7.
Whoops.
Oops, sorry, my bad. 3x minus 7 equals, and then Gianna, what's the other side?
8.
8. Okay? Boom, I've got rid of the 2, right, Brian? Okay, so Brian, what next should I get rid of?
7.
Good! You want to get rid of the addition and subtraction next. It's subtracting 7, so what's the opposite of subtracting 7? Brian?
Add.
Add 7. So I'm going to add 7. Again, both sides. These 7s create a 0. 0 plus 3x is 3x. That's how I get rid of it. The other side, what's 7 plus 8? Anyone? Anyone? Hands, hands. Bueller? Bueller? Yes?
15.
15.
15.
15.
Always raise your hand after you know the answer.
Oh.
Okay, so, all right. So Canyon, what should I do next? I'm down to here.
Times it.
So this says 3 times what?
3
3 times X.
To divide it.
So I gotta do the opposite. Very good. So I've gotta do the opposite. I gotta divide it. Okay?
5.
So this will be 5, right? Good. And you're done. Okay?
No, we're not done yet. Let's check it.
Ah, we gotta check it. All right, let's check it really quick.
Oh, damn, you
3 times 5 is? Well, it's easy. 3 times 5 is?
15.
15 minus 7.
8.
15 minus 7. 8. 8 divided by 2.
4.
4. That's what it started with. Like I said, it's really quite easy to check it. It doesn't take very long. Okay, Griffin. What's different about this one compared to these 2 problems?
There's more than one X.
Ah, very good. There's more than one x, but they're both on the same what? Side. If they're already on the same side, add or subtract like terms. You want to write that in your notes, by the way, somewhere. Okay, if they're already on the same side of the equation, add or subtract like terms. Let me show you what kids do, and I'll show you why this problem is one of the most missed problems. I see kids do this all the time. What's the problem with that?
You add them.
Yeah, you have now subtracted 6x from the left, and what have you done to the right?
Nothing.
Nothing. It's not equitable at all. This kid's gonna be really mad that you took $6 from him, and this kid didn't get anything taken from him. Are you with me? So this isn't equitable at all. Very bad. Don't do it. Okay. Wouldn't be prudent. Don't do it. All right, so now what should we do? What should we really do then? I want to combine these like terms. Just simply add them. Okay, or if there was a subtract between them, just simply subtract them. So what's 3x's? This is just like when we were adding up the angles, right?
7.
What's 3x's plus 4x's, Griffin?
7.
7x's. So this is 7x minus 7 equals 15. Okay? Now what should we do to both sides, Nick?
Now you minus this 7.
No.
Okay, it is minusing, so I've got to do what again?
Oh, plus.
Opposite. I got to add the 7. Okay, so this is 7x, because this has gone away. This is 0. And so this is 7x equals, what's 15 plus 7?
22.
Ooh,
22.
yeah.
Okay? And what should I do next, Nick?
Divide by 7.
Good. Divide by 7, because it's multiplying. Got to divide by 7. So I end up with x equals 22 sevenths, which is about pi, by the way. But now, notice I just left that as an improper what? Fraction. It's right. So leave it as an improper fraction. You can put it as a mixed number if you want, but it's not worth it. Okay? It doesn't go into it evenly, so I just leave that as the answer. Okay? Should I freak out if I get a decimal or a fraction answer? No. Don't. It's okay. Make sure you have the steps right, and then maybe check it and make sure. Okay? So I'm going to check it right here just because it'll be easier. Because I have a 7 denominator, that's a 7 numerator. They'll divide out, right? So what these 7s will divide out, that'll leave what? 22 minus 7. What's 22 minus 7?
15.
15, boom, same thing, okay? You can plug it in the other one, it just would take you longer to do, but I don't wanna take a long time, so we're good. All right, Gannon, what should I do here?
Get the X alone,
Okay, how am I gonna do that?
divide, times,
Tell me what?
add 4.
I'm gonna add 4, okay, good. He recognized something. This was a division line over both, are you with me? This just means x divided by what?
3.
3. This is not, it is a division line, I mean, it looks like a division line, but it's not over the whole equation like this one was. So Gannon correctly said, hey, it's probably gonna be easier if I just add the 4. This is x divided by 3 equals 11. Now, what's the opposite of divide?
Times,
Times, so I'm gonna multiply both sides by what?
11.
Nope.
3.
You're trying to get the x by itself, I wanna multiply by what? 3. See, if I multiply by 3, those divide to 1. I have x, and then I times this side by what?
3.
And I get 33, okay? So a divide line is different than a division line for the whole equation. If the whole equation is over a division line, I get rid of that first. By the way, could I get rid of this first? What if I had said this? And some people do this, I kind of do this every once in a while, honestly. I don't like having fractions, it makes my life more difficult, right? So how do I get rid of the fraction? Just times by what? 3. And I just distribute that. Remember how we looked at the card? Didn't we look at the card?
No, we haven't looked at
We
the
didn't
card
look at the card? Okay.
because we haven't done distribution.
So, all right, so all I'm gonna do though is distribute that, multiply it, that's what distribute means. I'm gonna multiply it across. So these 3's divide out, what do I get? X. But that 3 has to get distributed here too, minus 12. That 3 has to get distributed there too,
Don't look ahead.
21. Now I should add what? Add 12. What do I get?
20.
Same thing.
33.
Same thing. Here's why I don't necessarily like doing this one as much. The numbers got a lot what?
Bigger.
Bigger. Quicker. Think about this. Add 4. 7 and 4 is easy to add. Add 12 to 21. A little more difficult. So I prefer doing it this way. But you can do it this way and it won't hurt. The key is distribute to every single term. Okay? All the way across. Because then you're multiplying to the left and the right, and you're multiplying to every term in between. Okay? Everything would have to be multiplied by 3. But that's a little harder to think of than this. This is easier to think. Okay? Next one, Logan. What should I do here?
Combine the X's.
Yeah! The x's are on the same side of the equation. So if they're on the same side, I just simply combine them. What's 4 minus 5? Negative x, right? Plus what? 7 equals 13. Okay? Tristan, what should I do next?
You gotta find out what the x is.
That's what I'm trying to do. You tell me what to do to get there.
Oh. Well, you gotta minus the 7 and 3.
Good, minus the 7. I'm trying to get that x closer to being by itself. Negative x equals 13 minus 7.
6.
6. Okay. Now what? The x is by itself, but what's in front of it? The negative is in front of it. How do I get rid of a negative? Yeah, I can times by a what? A negative. What's a negative times a negative? A positive. But then over here, what will I have to times by?
Negative.
A negative. It's still -1, really. By the way, there's a -1 here, really. So I'm going to times both sides by a negative. And a negative times a negative is a
Negative. Or positive.
positive. This side, though, it's a positive times a negative, so it's a -6. That's my answer. So not only do you have to get the x by itself, but you have to get the x by itself, and it needs to be what? Positive. Okay, that's something you might want to write in your notes also. Your goal when solving an equation is to get the x by itself and positive. Okay, x by itself and positive. Okay, let's try the next one. Okay, this one's an interesting one. Okay, what do I need to get rid of on this one? You might want to watch this one even if you think you know what you're doing. Jacoto, what is on the same side of the x? The -4 and -3. But the -3 is in front of a parenthesis. So what's the -3 doing to this whole thing?
Times
Timesing. How do I get rid of times?
it. Divide.
So I'm going to divide the whole thing by what? -3. That leaves what? X minus 4 equals, what's 30 divided by -3? That's pretty easy. -10. Now what should I get rid of, Dakota?
+4.
Add 4. And again, I'm adding 4 to the -10. X is what? -6. You're done. Okay? Now, is there another way I could have done that one? Yeah, and I'll do the other way over here. Could you have distributed right off the bat? -3 x minus 4 equals 30. Could I distribute? Yep, you can distribute. It'll just make things a little what?
Large.
A little bigger, but it's okay, you can do it. This becomes -3x. What's negative times a negative? Positive 12 equals 30. Okay? But now I don't have parentheses anymore, so that's good. So now what do I do? Minus the 12, good. And what do I get? -3x equals, what's 30 minus 12? What's 30 minus 10? What's
20.
30 minus 10? 20 minus 2 more is 18. Divide by -3. What's 18 divided by -3? -6. Would you get the same answer? Yeah, you get the same answer either way. Okay. But that's what you can do. Now this one, I might do that first. Why? How many variables are on the right?
2.
So this one I prefer multiplying. This one I prefer what?
Dividing.
Dividing. But this one I prefer multiplying because I got to combine the like what? Terms like Logan had us doing, right? Okay, so Tristan, what am I going to get when I distribute the 4? What's 4 times R?
I don't know. We don't know what R is.
I don't. What's 4 times R then?
4R?
4R. Yep, that's just 4R. I just leave it as an R. Okay, because I don't know what R is. So I'm just going to times it. 4 times 1. 1's in front of the R. 4 times 1 is 4. R.
You're good. Just keep going.
Do you have my money?
What?
All right. I think we won.
Oh yeah, you did. That's what I was gonna come talk to you about.
I'm so excited.
Oh my god.
What do we win? $10?
I don't know. I'll look. The
So,
girl sent me it.
I was pretty excited. I was like, dude, we won. All right. 4 times -3 is what?
-12.
-12. Okay. So, Tristan, the key is distribute to both terms. Multiply it both to the R and the -3. I see a lot of kids write 4R minus 3. What'd they forget to do? Times the 4 to the what? 3. Anytime you see a parenthesis, you've got to distribute. You've got to multiply through 4R minus 12. Okay? Now what?
Combine like terms.
Think about this one. Let's ask Logan. Logan, what should I do with this? Combine like terms. See, he's really good at that. He sees the 2 R's, and he says, I got to add those together. So I get how many R's there, Logan? 8R. Okay, minus 12. Okay. Now what? Bailey?
Close.
Bailey or Brayley?
Brayley.
Brayley?
Yeah.
Okay. Brayley, what should I do to get the R by itself?
I need to add, is it 8 full size?
Okay, so should I add 8?
Sure.
Let's add 8. What's 8 plus 44?
40.
52.
52 equals 8R. And then what's -12 plus 8?
-4.
Well, that's nice, but did it get us very far?
No.
No.
Plus,
I mean, you're on the right track. We're at it. That's good. But by the way, what did I just show you? Does it really matter as long as you keep doing it to both sides? No, it'll make the problem longer, but it doesn't hurt anything. You're not out anything if you mess up. Okay? So Brady said add 8. She probably was thinking this 8, but hey, wrong. If she says add 8, we can add 8. Is that okay? Yeah, it's not gonna hurt anything. What should I do next then?
+4.
I probably want to add another 4. Because I really should have added 12 originally, right? But it's okay. It's not going to hurt anything. We're okay. What's 52 plus 4?
56.
56 equals 8R. What should I do to both sides, Griffin? Divide, because 8R means 8 what R?
Times.
Times R. I got to do the opposite as I'm working backwards. I got to divide by 8. So R is what?
7.
7. Okay, Danny, I want you to think with me here. Start with 15. You with me? You're at 15. Thinking about it? What's the next even number? Or sorry, odd number. What's the next odd number after 15?
17.
17.
How'd you get there?
Because these get something.
Think about how you got there though.
Add 2.
You added 2. Very good. Okay, you're at 17 now, Danny. How do you get to the next odd number?
Add 2.
I just keep adding 1.
2.
So if the first odd number is x, what's the next odd number?
X plus 2.
X plus 2. I'm adding 2, not timesing by 2. So don't write 2x, write x plus what? 2. What's the next odd number?
X plus 4.
Good, it's 2 more, so it's x plus 4. Who said x plus 4? Very good, Seth. That's actually really smart to say that. What would the next odd number be?
X plus 6.
And I can keep going, right? I just have to keep adding 2 every time. Danny told us we just added 2 more, right? So we just keep adding. Okay, now think of an even number. So, Canyon, 26. You with me? What's the next even number?
28,
How'd you get there?
is that is add 2?
You just added 2 and we're doing evens? I thought we just did that with odds. Does it matter?
No.
No, doesn't matter. So Dakota, if he's at 28, what's the next even number? So you added what? Another 2, right? Added 2 more. So if I start with an even number being x, what's the next even number?
Plus 2.
X plus 2. What's the even number after that? Logan.
4.
X plus 4, right. Don't write 4x. That's where kids mess up, is they put it timesing when it should be what? Adding. And then, by the way, this just keeps on like that. So is there any difference between whether it says even or odd? No. If I start with an even number, the next even is 2 more. If I start with an odd number, the next odd number is 2 more. It's all good. Okay? Now, let's do both these then. 3 consecutive odd numbers have a sum of 57. What does this word mean?
Add.
Yes, or you hit your finger with a hammer. And you say, son of a! That's what I say. Anyway, I don't know what you guys are saying. Because I'm a math teacher, though, probably. That's what you say, right, Danny?
What?
Son of a, when you yeah. Totally all say. All right, so 3 consecutive odd numbers have a sum of 57. What does sum mean? Add. 3 consecutive odds, what are they? I don't know for sure, right? This goes back to what Tristan said. Well, I don't know what X is. I don't either. But I know that the first 3 consecutive in a row odd numbers would be what? X plus what?
2.
2 and X plus 4. Sum means I should do what with those?
Add them.
Add them together. So add like terms. Gannon, what am I going to get?
6.
3x.
All 7 with the X.
3x.
All 3X.
3x. Do you guys see where he was getting 6? He added these, which is fine. That's the next thing I'm going to do. So what's 4 plus 2?
6.
Plus 6. So he wasn't wrong. He just added the non-variables first. But that's 6. This is 3x. What should it equal?
57.
Nope. The
Two.
three consecutive odd numbers have a sum of, so I just set this equal to what? 57.
So, 60.
And then I can solve it, can I? So what's the first thing I should do?
Minus 6.
Minus 6, Seth says. Then I have 51 equals 3x. What should I do next?
Divide.
Divide by 3. Do that on a calculator.
17.
X equals 17. That's the what integer?
First.
That's the first one. So if 17 is the first one, what's the next one, Canyon?
What?
If 17 is the first odd integer, what's the next odd integer?
19.
I'm adding 2.
Yeah.
That's all I'm doing. 19. If I take 17 plus 4, what's the next odd integer?
21.
21. Those are them. If I add all three of those together, guess what they'll add up to?
57.
57.
That's it.
Is that right? I hope, because that's what I did, so I'm hoping that's right. Okay, let's do this one. Okay, let's do this one right here. Okay, Logan. What should I write? Three consecutive even numbers have a sum of 144. What equation should I write? 3x. How did he get 3x, you guys? Yeah, he just had x plus x plus x. He just added those three x's. Plus what?
6.
Is it any different than if I was doing the odd? No, just different in what it equals. It will equal what, though?
144.
144. Subtract what?
6.
6. That's going to give you 3x equals
138.
138? Okay. Like I said, I'm really bad at math. Kate's really good at math. It's really weird. Because I can't add or subtract to save my life, honestly. But I know the process, I just don't know how to do it all in my head. I'm not that good at math in my head, honestly. All right, Dakota, what should I do next? Dakota, what should I do next? 3x equals 138. Divide by 3, good. Divide by 3, x is what?
46.
46, I'll trust you. Now, that isn't the final answer, right? Brian, what's the next one?
44.
46 is the
Go-
first
go
one. The
up,
next
not
one
down.
is, you got to add 2. So
48.
48 and add 2 more,
50.
50. If I add those three together, guess what I'm going to get?
144.
144. Pretty cool, huh? Okay, let's do the last one. This is number 17 off your assignment. Okay, so take out your assignment. It's going to be 1.2,
Page 11.
page 11 and 12, or 10 and 11, sorry. 10 and 11, we're doing 17. We're going to have, the only kid I haven't called on today, what's his name in the back?
Ryder.
Ryder. Is that right? Yeah. Okay, Ryder, read me number 17. Everybody else, watch what I do while he reads it. Because this is how you do a story problem, honestly. You just listen and write it as you read it, okay? And you can't get it wrong. Write it as you read it. Okay, go ahead, Ryder.
Your cousin is 8 years older than you.
Wait! This is the hardest question in the entire world. Let me explain why. Okay? There's twice as many boys as girls in this class. How do I set those things equal? There's twice as many boys as girls. What should I times by 2 to make them equal?
The girls.
The girls! I said twice as many boys. Your brain wants to do 2b, right? But really you shouldn't. To make them equal, you should times who? What by 2? I mean, look around. If there's twice as many boys as girls, which there kind of is, what should I times by 2? The girls to make them equal. So the same thing applies here. So read that part again.
Your cousin is 8 years older than you.
Your cousin is 8 years older, right? 8 years older than what?
Your brother.
Than your brother. So if my cousin is 8 years older than my brother, what should I add 8 to? If your cousin is 8 years older than your brother, what should I add 8 to make them equal? Think about that. Your what? Your brother. That's what's so tricky about this. You always have to think, and you might want to write this in your notes above that one or somewhere in your notes. Always think, how do I make things equal? Okay? That's the key to story problems. And that's what makes story problems hard. My brain wants to say, my cousin is 8 years older than my brother, I should add 8 to my cousin. But that would be wrong. Now my cousin is 16 years older. You with me on that? If your cousin is 8 years older than your brother, you got to add 8 to who?
Your brother.
Your brother, not your cousin. That's where most people mess that up. Okay, now we got it. Okay, my cousin is 8 years older than my brother. Did I write that on the board?
Yeah.
Yes. Okay, I had to think about how to make them equal, but I wrote that on the board. Okay, go ahead.
3 years ago, your cousin was twice as old as your brother.
3 years ago, my cousin was twice as old as my brother. Who should I times by 2?
Cousin.
If my cousin is twice as old as my brother,
Oh, times.
I should times which one by 2?
Brother.
The brother by 2. But this was 3 years what? So what should I do with the B?
-3.
Minus 3. What should I do with the C?
-3.
Minus 3. Because this is right now, right? And this is 3 years ago. Okay? Now what?
How old is your cousin now?
How old is my cousin now? Now this is a simple substitution problem. And so let me explain that. What does your cousin equal? What does the letter C equal?
Cousin.
B plus what?
8.
8. So what can I replace this C in this other equation with?
8.
B plus 8. Now why would I want to do that? If I have this equation, can I ever solve it? Never. I can solve it for C or I can solve it for B, but I'm not going to solve anything. If I have 2 variables, I've got to have how many equations? 2 equations. I do, but I've got to use one equation to help me solve for one variable in the other equation. I got to turn it into a 1 variable equation. Okay? So I'm going to substitute for one of the variables, and that will allow me to solve it. So I have 2b minus 3 equals b plus 8 minus 3. Now this is a pretty complicated equation. This is what we're going to do tomorrow, really, is this type of equation where we have b's on both sides. But I can still solve this. I'm going to distribute, and over here I'm going to combine like terms. So I'm going to do 2 different things, kind of not exactly at the same time. Seth, what am I going to get when I distribute the 2?
2b.
Or not to be, that is the question. Okay, go ahead.
3b.
Nope.
-6.
Minus.
Minus
6.
6. Don't forget to distribute the 2 to the 3. Like I said, that's the biggest mistake made on these, is you forget to distribute. Okay, on